A pleasant morning to everyone. I am Raziel Mosquite and I'm going to discuss about the Roman mathematics. So we have objectives is to have knowledge about the history of mathematics in Rome, to to identify the usage of mathematics and the purpose of Roman numerals, to show the contribution of the Roman to the people, definition, and facts. So we have a brief history about Rome mathematics. So, by the middle of the first century before Christ era, the Roman had tightened their grip on the Old Greek and the Hellenistic empires, and the mathematical revolution of the Greeks ground the whole. So the Romans were the dominant empire on the earth. So overview, the numeral system developed by the Romans was used by the most Europeans for nearly 1,800 years, far longer than the current Hindu-Arabic system has been in existence. So Roman numerals is originated in ancient Rome. This ancient counting system is believed to have started with the ancient Etruscans. So, Roman numerals were developed so that the Romans could easily price different goods and services. Next is Roman numerals are written as a combination of 7 letters. So, within this topic, we already talk about this when we was at the elementary years. So Roman numerals has a combination of 7 letters, which I is equal to 1, V is equal to 5, X is equal to 10, L is equal to 50, C is equal to 100, D is equal to 500, M is equal to 1000, and A and has the line at the top is what we call the vinculum. So, the letters should be arranged from the largest to smallest if you are going to write a Roman numerals, unless it must show a lesser numeral. For example given is, we have the 4 number. If you are going to write 4 numbers, you don't need, you can what do I call this? You can't repeat the letter more than 3 times. You are going also to repeat the letter 3 or thrice. So, if we are going to write 4 is, we're going to write I and V. Also, 249, I and L. So, C is equal to 100, not X, 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 too many repeat. So, if you are going to write, don't repeat it more than 3 times. So, we have the Roman additions, and there's a rules that convert subtractive prefix to normal, and concentrate both the numerals in descending order. So, do not I do the normal sums like I 5I is equal to V, but don't write but don't ever write 4I is equal to 4. But then on you're gonna going to write I and V. So final answer should be in subtractive prefix if required. Final answer should not have V and 4I, convert it to IX. So, like for example, we have 36 plus 74. 36 is in Roman numeral is XXX, V and I. Then 74 is you're going to write and you're going to expand it by writing 7x and then 4i. In addition, you are going to add the same letters. So at the first, we have 3x and then 7, and the second one is 7x. So you are going to write 10x. So, and then the same process to the next letter. So that CV and then 5i. So the 5i is equivalent to letter V. So that CVV. And then V plus V is equal to 10, and then you are going to write X. So that our final answer should be CX is equal to 100. The next, Roman subtraction. The rules is convert subtractive prefix to normal. Example given is 4 is equal to 4 or 4i, and then ix is equal to v and then 4i. So remove common symbols. No number should be present before the negative sign or the minus sign. So example is 234 minus 103. So 234 in Roman numeral is equal to CCXXIV minus 100, which is C and then 3I. So if you are going to subtract it, you are going to minus CL and then X and IV minus the CII, and then you are going to subtract the or cancel the same letter if you are going to subtract the Roman numeral. So the same as the Roman addition, but in Roman addition you are going to add, and then here in Roman subtraction, from the word subtract you are going from the word subtraction you are going to subtract. So that is the Roman subtraction. So next is 0 in Roman numerals. 0 in Roman numerals is, it is believed that 3 was 0 in Roman numerals, but this has no Roman numeral. The digit 0 is only used as positional number system such as decimal. The number 0 has no use in terms of writing and mathematics operation. So here in 0 in Roman mathematics, the representation of 0, orally it is called nulla or nihit, which means none in Latin. So Roman 0 in Roman mathematics is the first modern equivalent of numeral 0 comes from a Hindu astronomer and mathematician Brahmagupta in 628. His symbol to depict the numeral was a dot underneath a number. So next is the abacus. The Roman abacus, which was developed by Ancient Roman, is a portable and base or 10 version of earlier abacuses like Greeks and Babylonians. So it is believed to be that the first portable calculating device for engineer, merchants, and tax collection. So next is Roman calendar. So Roman calendar borrowed some earliest calendar in Greek. The first and the earliest Roman calendar was introduced by the first emperor of the empire, Romulus, in 70s before Christ era. So Numa Pompilius was the legendary second king of Rome and added January and February to the calendar, which made it to 300 days in the calendar. So as you can see, in the calendar, we have, in 1 year, we have 365 days now, or if there's a 29 in February, we have the 366 days. So next is mathematics teaching in ancient Rome. The Roman educational system was very similar of the Greeks but had certain differences. The Roman used applied mathematics. It is used in the physics and engineering. So they are learned most for practical purposes like trade and commerce. So Ptolemy, his real name is Claudius Lomedius, but we know him as Ptolemy. Not much is known about his life. The name Claudius probably means he was a Roman citizen. The name Ptolemy means that he was Greek. So Ptolemy is a Greek. The Ptolemaic system was a geocentric system that postulated that the apparently irregular paths of the sun, moon, and planets were actually a combination of several regular circular motions seen in perspective from stationary Earth. So, we have Papias of Alexandria. Papias was born 290 AD in Alexandria, Egypt. There is little known about Papias' life, but according to his writings, he was a teacher at Alexandria. He is known as the less Greek mathematics. Papias is known for his synagogue or collection. He died in 350 AD. So, Papias' synagogue, there are at least 8 books in his collection, some which include geometry, recreational in mathematics, doubling a cube, polygons, and polyhedrons. So, there is only one Greek copy left today. Book 1 and 8 don't exist, and only some of books 2 to 7 are all intact. So, that is the Roman mathematics.